Greetings, class. This is Dr. York-Hammons. We are still working in Chapter 8, Section 2, testing the difference between two means when you do not know the population standard deviation for either of the samples. Now, we're going to look on page 433 of the e-text, question number 18, and there is a large set of instructions for this. We have to, first of all, identify the claim and state H sub O and H sub A. Find the critical values, T sub 0. It could be, depending on whether it's a left, right, or two-tailed, you may have one or more than one, and identify the rejection regions that go with T sub 0. Find the standardized test statistic T and decide whether to reject or fail to reject the null hypothesis. And E, interpret your decision in the context of the original claim. The nice thing about it is that they tell us to assume the samples are random and independent and the populations are normally distributed. We must have those conditions in order to run the t-test for two samples in the first place. So let's look at our problem. This is a little different from numbers 10 and 12 that we did on the last video. 10 and 12, they gave you all the data and told you what it was. In 18, it's written out for you, so we kind of have to read it and find out. So let's just start reading. A personnel director from Hawaii claims that the mean household income is the same in, I don't know how to pronounce this, Kauai County and Maui County. In Kauai County, a sample of 18 residents has a mean household income of $56,900 and a standard deviation of $12,100. In Maui County, a sample of 20 residents has a mean household income of $57,800 and a standard deviation of $8,000. At alpha equals 0.10, can you reject the personnel director's claim? And we're going to assume that the population variances are not equal. So the first thing we have to do is look at that first sentence. A personnel director from Hawaii claims that the mean household income is the same in Kauai County as in Maui County. So we would say that mu1 was equal to mu2. So I'm going to type this in and come back to you in a second. So I've added in some information for H sub O and H sub A, and we will look back at this and see what it's asking. It says a personnel director from Hawaii claims that the mean household income is the same in Kauai County as in Maui County. So if they're the same, that means you would use the equal sign, and since it's an equality symbol, we know that that is H sub O, and in this case, this is our claim, not the alternative hypothesis. Now, what symbol would we put here for H sub A if H sub O is equal? We need its complement, so the complement of equal is not equal. So I'm going to insert a not equal symbol, and that would be our alternative hypothesis with the not equal symbol. Maybe I can make that just a little larger for you there. So that's the not equal symbol. Now, as a reminder, StatCrunch is going to use the difference. So if they are equal, if mu1 and mu2 are equal, then their difference is 0. And if mu2 is not equal, mu1 and mu2 are not equal, then their difference is not equal. So I would insert the same symbol, the not equal sign that I did for H sub A over there. Now remember, in this case, mu1 is going to be Kauai County and mu2 will be Maui County. So we have some data that they provided for us. So I'm going to insert a little table. And in that table, we're going to talk about sample 1, that's Kauai County, and sample 2 is Maui County. The first thing that it's going to ask you for in your data is going to be the sample mean. So let's find the sample mean. It says in Cowie County, a sample of 18 residents has a mean household income of $56,900. So 56900. And for Maui, it says in Maui County, a sample of 20 residents has a mean household income of $57,800. So 57800. The next thing it's going to ask you for in StatCrunch is the sample standard deviation. So in Cowie County, 18 residents, mean household income of $56,900, standard deviation of 12,100. So that's 12,100. However, in Maui County, a sample of 20 residents has a mean household income of $57,800 and a standard deviation of $8,000. So that we would put 8,000 with our second sample. And then the last thing you'll have to input is the sample size. So for Cowie County, it was 18 residents. And for Maui County, it was a sample of 20 residents. And it says that alpha is 0.10. Can you reject the personnel director's claim? Can we reject H sub O? And assume the population variances are not equal. Well, I'm going to need to pull StatCrunch up and run through the test in order to determine if we can reject or not. So I'm going to pause this and get us set up with StatCrunch. All right, so we're back, and I've got this set up where you can see our information from the problem number 18, and we're ready to do StatCrunch. Now remember that if we are not given the population standard deviation, we have to do a t-test. So that's what they're asking us here, is to do a t-test. We've identified the claim. We stated H sub O and H sub A. We have to find the critical values and identify the rejection regions. So if you want to find critical values that they call T sub O, looks like a 2, but that's really T sub O. In this case, we're going to do a two-tailed test because we have the not equal to sign in your H sub A. Now, in order to do this, you have to use the T calculator. So when we're finding critical values, we use the T calculator. So I go to Stat, Calculators, T. Now, because it is a not equal, on the T calculator, we're going to use the between option. And then the other thing is that normally if it was a left or right, you would just put alpha there. But since it is a between, we have to use 1 minus alpha for our area. So 1 minus 0.10 is 0.90. And when you click compute, it shows you that your T sub 0 values, I'm going to scroll down a little bit so you can see those a little better. We get T sub O equal well actually it's negative T sub O. Negative T sub O equal negative 1. We'll just do 3 decimal places, 813, and T sub O equal a positive 1.813. And that's to 3 decimal places. But what are the rejection regions that are associated with those two T values? So what you have to remember, and it's only when it's the between, is that the actual rejection region is in white because we use the 0.90 for the red. So this is where everything's okay. You would fail to reject, but anything that's out here to the left or anything that's out here to the right of the positive value will be the rejection regions. So it will be any of your standardized t values that are less than a negative 1.813, or any t values, your standardized test statistic, that's greater than 1.813. So if you're in this left side, less than negative 1.825 or 813, you're in the rejection region. And if you're on this right-hand side where you are greater than that 1.813, so if you're out here anywhere or you're out anywhere on the left here, you're in the rejection region. So we still have to find our test statistic, find the standardized test statistic. So we've used the t calculator. Now we use the t stat. It is to sample with summary, and we have to type in the data from our table here. So the sample mean was 56900 for the first, 12100 for the standard deviation for this sample, and the sample size was 18 for Cowie. Now for Maui, our second sample, the sample mean was 57800. The sample standard deviation was 8,000. The sample size was 20. So I got all that information from these two columns in this table that I used, created from the problem. Now, we have to decide if we have to pool our variances. It says, assume the population variances are not equal. So you uncheck that box. Be sure this box is blank because the population variances are not equal. Now, we are using H sub O as mu1 minus mu2 equals 0, so that's correct. And the symbol for H sub A is not equal. That's correct, so we're good there. And I'm just going to have it store the data in the output table. And so when you look at this, you see this t stat equal negative 0.267332. So that is your standardized test statistic. And I'll just copy and paste. That's your t stat. And that's approximately equal to, well, let's just take 3 decimal places, 0.267. Now, since it is negative, we would look at this negative value. And I'll pull that table back up, or graph, excuse me, the t calculator. And let's see where negative 0.267. Well, here's 0, here's negative 2, here's negative 1. Negative 0.26 is really close to 0 on this left side. So it's in what we would call this safe region, because remember when we use the between, it's backwards. The red area is that you're not in the rejection region. So even though I'm here on the negative side at negative 0.267, I'm not over here. I'm not in the negative 2 to 3 to 4 to 5 to 6. I'm a really small negative value for my standardized test statistic. So this is not in the rejection region. It's not over here less than negative 1.813. It's not over here. So we fail to reject H sub O. Now, this is just if you check your p-value, I'm just going to go ahead here and have you check your p-value. Notice that p-value is 0.79. That also is bigger than alpha, so that's another way you can see that you would fail to reject. Since you failed to reject, we have no evidence to support the